Hello everyone, I hope you are doing well. So in this video, we are going to discuss Geeks for Geeks problem of the day, and today's problem is largest sum subarray of size at least k, right? So this problem basically says that we have been given an array, we have to find the largest sum subarray which has at least k elements. So similar to Cadence algorithm, in Cadence algorithm there can be minimum 1 or 0 elements, here it has to be at least k elements, right? Now we are going to solve some in somewhat similar fashion to Cadence algorithm, but this problem is very different in terms of implementation, right? So what do we have here? We have been given, let's say this particular example, the size of array is 4, we have 4 elements here and the minimum size is 2. So as you can see, we can consider this particular subarray of size 2 which has a total sum of -1, and this is the maximum sum subarray possible of size at least k, right? So I'll try to divide this problem into two parts. So first of all, let us say maximum sum sub array of size k. Right. So this is our initial problem. I want to divide this problem into two halves. So the first half will be uh, finding all subarrays of size k. So this is going to be the first half of my problem, and the second half is going to be trying to extend those subarrays. Right. So this is how I'll try to deal with my problem. So this is going to be my first half and this is going to be my second half, right? So let us consider about the first half first, right? So what do we have here? Trying to find out all the subarrays of size k. I have misspelled it here, so it should be like this, right? Now if I have an array, so let's say I have an array like this, I want to find out all the subarrays of size k. So let's say k is 2 here, right? So what can be the subarrays of size k here? The first subarray will be this one, then the next one will be this one, the third one will be this one, fourth one will be this one, and so on. Now if I ask you to calculate the sum of all of these subarrays independently, how can we essentially do that? Let's say this is A, this is B, this is C, D, E, F and G, right? These are all the elements. I want to find out the sum of subarrays. So initially what I'll do is I'll take the sum of the first two elements. Now I have my sum is equals to A plus B, and this is essentially the sum of my first subarray of size 2. Now I'll keep a pointer. My pointer will be at here. Now in order to get the next subarray, what I'll do, I will add C to this particular sum, and I will subtract A, So my sum essentially becomes, now sum becomes B plus C, right? And how did it happen? I will add the element that is present at the current position and I will remove the element that is present at the current position minus 2 index. Why 2 in this case? In a more general case, we will take k, right? So this is my current position P and k is the size of the subarray. So this is how I can move on to the next subarray. Now in the next iteration, my pointer will move forward and now my D will get added to the sum and B will get removed from the sum. So what essentially happened, my sum has now become C plus D, which is the size of the next subarray of size 2. And how did it happen? I just added the element at the current index and I just subtracted the element at the P minus kth index, right? So this is how I can eventually find the sum of all the subarrays. Now my second question was, should I try to extend those subarrays, right? This was my second task. Let's say I figured out, let's say that the sum of B comma C is something, right? Now should I try to extend this particular subarray, because now I have satisfied the minimum condition that it should be of size k, right? Now I have two choices, whether I can try to extend this particular subarray from here or I can restrict this subarray till here only, right? So with B plus C, let's say my current sum is B plus C, I can try to include D and then try to include E and then try to include F and so on. Otherwise, I can write P plus C only, right? Now, it depends on what is the maximum sum of the subarray starting from this particular position, right? It all depends on this particular task. So, now our question or the second part reduces to finding the maximum sum subarray starting from the current position. That basically means if I start from this particular element D, what is the maximum subarray sum I can find? And in this particular case, I have to take the element D and start from here, right? I cannot be like, I cannot be starting from E and so on. I have to start from D and then try to include other elements. So, let us say we will try to solve it with dp. Now, the dp is not very difficult, it is a simple single dimension dp here, right? And here the idea is very similar to cadence algorithm in this particular part, right? So, let us say this is some element f, right? Now, the answer, and let us say the f is the last element and here it is 0, right? Because this is the last element, this is the position which is past the last element, and the maximum subarray sum starting from this particular position can be 0 because all the elements have been exhausted, right? So, this is going to be, let us say this is my original array and my dp array is going to be here, right? Now, if I start from this particular position, what is the maximum subarray sum that I can form? So, for this particular position, it can be f only, right? Because there are no next elements and this element can be f only. Now, if f is negative, I will mark my dp of, let us say this is last index as 0. Why? Because if I want to start from this particular position, instead of taking the current element, if it makes a sum negative, instead of taking it, I can just ignore it and make the sum 0, right? If it was greater than 0, then I could have taken f only, right? Now, let us say that there is some element g here, right? Now, I have two choices here. The first choice is on g itself, whether I want to start the sum from here or not, right? But let us consider that we are taking g. Now, I can try to take f or ignore it, right? So, the next element is f. I am currently taking g and I can try to take f or not, and not specifically f, it is actually the answer of dp of I plus 1. So, I is the index at which g is present and dp of I plus 1 will store the maximum sum of the subarray I can start from this particular position, right? Similarly, let us say some e was here, right? So, at this particular position, my answer can be e plus dp of I plus 1, where I plus 1 in this particular case is the next index. So, what I am saying is I am taking the current element and I will take the maximum sum subarray which you can start from this particular position, right? If this whole value is positive, then well and good. If this whole value is negative, I am going to take 0 instead of it. Why? Because if starting from this particular position, my maximum sum subarray is negative, then it's better to take 0 instead of taking a negative number, right? So, in this particular case, let me just write it also. So, what I'm going to do here is, let's say I have a helper function and p is my current position, right? Now, what I'm going to do is, if p is equals to n, I'm going to return 0, otherwise I'm going to return dp of ps is equals to a of I plus my helper of I plus 1. So, let me expand it. So, you see what is basically happening here is, if we have reached the last index, I am just going to return 0, otherwise I am going to set my dp of p as a of I plus helper of I plus 1. Now, you can also take the maximum of this, maximum of 0 comma this particular value, right? So, now basically what is happening is, I am depending my answer on a of I plus helper of I plus 1, right? So, what is happening? I am taking this current particular element and I am asking the answer for the next index. What is the maximum subarray sum if I start from the next index? I add both of these values. If this value is positive, then well and good, otherwise I am going to take 0. That means the maximum subarray sum I can start from the current position is 0, right? Now, what is basically happening here is, I have figured out both the paths, this part and this part, and I am trying to find the size or the sum of the subarrays of all the subarrays of size k, Now let's say I figured out that the current subarray is B plus C. Now I said I also figured out what is the maximum subarray sum I can start from this particular position. So that is dp of I. So in this case, let's say D was present here in this is position I. So this would be the best answer if I start from the B element, right? Let's say if I start from the E element, so that would be E plus F plus dp of G. Let's say this is the G position and this would be my best answer if I start from the E element. So basically I am taking the first two elements, that is the size of the subarray, and I am saying find me the best subarray which starts from this particular position, right? So this is how we can solve this particular problem by breaking the problem into two parts. So in the first part we satisfied the minimum condition, that is the size k, and in the second part we tried to extend those subarrays of size k if the sum is going to increase, right? So now let me show you the code what I have done. So I created a dp vector. I also use a prefix vector initially, but it is not required now. So I created a dp vector, and in dp basically what I am doing is I am creating a reverse for loop. Why reverse for loop? Because my state I is depending upon state I plus 1, that is why state I plus 1 has to be computed before computing state I, right? So dp of I will be equals to a of I plus dp of I plus 1. Now dp of I should be set to maximum of dp of I comma 0, right? If this dp of I becomes negative, it's better to take 0 only, right? Now we initialize my answer with minus a very large number. So this is, let's say, minus infinity. In this particular case it is 10 to the power 18. Now I've initialized my current sum with 0, and I'm going to take the sum of the first k elements in my current sum. Now I'm just going to create a simple for loop. So this position is k. So I here is basically representing what is the element after ending the current subarray. So basically if my current subarray ended at C, then my I is pointing towards the next element in this particular case, right? So my sum is basically equals to current sum plus dp of I, right? Because this will be the element after ending the last element, and my answer will be equals to maximum of answer comma sum. Now when I want to shift the window, when I move on to the next subarray, I am going to add current sum plus is equals to array of I. So this I is basically this new element that has been added, and I am going to subtract I minus k, so the last element will be removed. Now at the end I am also taking the maximum of answer comma current sum. Why? Because when my subarray is, let's say, this one f and g, my I will be here, right? And this will never get executed because I is only less than n. So my current sum will include the sum of the last two elements, and I also have to consider them in my answer, right? So that is why I take the maximum of answer comma current sum finally, and this would be my final solution. So the implementation you see is not very complex. It was just you have to break this problem into two simple parts, and then this problem becomes very easy, right? So that is it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye. So I just forgot to submit it and show you. So I'm just submitting it right now. So you see, pass all the test cases, solution is correct. That's it. See you in the next one.